Hey everyone, lesson 10.10, nonlinear systems. This is exactly what it sounds like. Systems that are not lines, nonlinear. Looks like our learning target does need to be changed here. The learning target should be, there we go, find solutions for systems that are nonlinear. We are going to do this mostly by graphing. You will see it done a little bit by substitution. This is not something that we typically do using elimination methods like addition and multiplication. So taking a look here, I'm asking you to solve the given equation for x. In the first one, remember there is no x. In this one, there's just an x squared, so reverse PEMDAS will be more than enough. If we go ahead and divide by 4, we find out that 4 should be equal to x squared, meaning that x is equal to the positive or negative version of 2. In the second one, we do have an x squared and an x term, so the quadratic formula is absolutely necessary. However, in this one, it is not quadratic ready. We do need to zero out one side completely by adding a negative 8. So we have just found out that 0 is equal to negative x squared plus 6x minus 9. Here we have parts A, B, and C. They will be entered into the quadratic formula. The first step of the quadratic formula involves calculating 4 things: 1, 2, 3, and 4. So what we come up with is negative 6 plus or minus the square root of 36 minus 36 over negative 2. Which comes out to be negative 6 plus or minus the square root of 0 over negative 2, which is really like negative 6 plus or minus 0 over negative 2, which is really just negative 6 over negative 2, a positive 3. The final one, I want you to go ahead and use the model that we just did in the orange one to go ahead and finish off this green one. One step at a time. You should see something that looks like what we see here on your paper. One step at a time. I'm going to go slowly just in case you need to change something or try to identify your mistake. To find a result of x equals 3 or negative 2. Now if we were to go back to any of these equations, we could try either of the blue solutions in the original blue equation, and they both would come out to be 16 equals 16. We could try x equals 3 in the orange equation, and we would find out that 8 equals 8. And if we were to try either 3 or negative 2 in the green equation, we would find out that 12 equals 12 in one case. And in the other case, it would tell us that 7 equals 7. So nonlinear systems, they include a nonlinear equation, like a quadratic, like one that we saw in our warm-up today. They're usually solved using one of the following methods: graphing, which is the preferred method. We will see a couple substitutions. I believe there are 3 actually in your assignment that are substitution. The rest will be solved by graphing. We're going to see 2 examples of solving a nonlinear system using graphing, and 2 examples of a nonlinear system solving using substitution. We're going to look over a few other examples in class as well. So the first one asks us to solve the system y equals 2.718 to the power of x and y equals 3.14 times 0.25 to the power of x. The graph that I used for this one was using the software that I downloaded from algebra.org. You can click on the link and download your own software. You'll notice that the equations are graphed here, and we've never seen an equation like this with a y equals and an exponent of an x. Each equation is graphed. You'll notice it has been done in function form. We've got a red function, f of x equals 2.718 to the power of x. It's our first one here. And then g of x, a blue function, 3.14 times 0.25 to the power of x as well. You'll notice that, as always, the intersection gives us the solution, the point where both graphs are satisfied. The red shows all the possibilities for the red equation. The blue shows all the possibilities for the blue equation. The part where the system, or both equations, is true is right here at the intersection A. which is given right here in this ordered pair. I have rounded to say that x is about equal to 0.48 and y is about equal to 1.62. Taking a look at another one, this graph I actually created using your CAS calculator. This one is the system of equations that y equals 9x plus 25 and y equals 2x squared plus 7x plus 1. Let's go. I had originally planned to use a cube, but then I realized that for graphing purposes, y and x were a lot more practical. So using the CAS, I graphed it. You'll notice again that the graph uses function form. The first equation is considered function 1 of x, 9x plus 25. We can see that being the line here. We know that is a line because it has an x term, but no x squared term. And then the second function, f of 2 of x, is equal to 2x squared plus 7x plus 1. That is our quadratic function right here. Using the graphing menu, I found the intersections. I went to a menu and points and lines. That's the 7th option on the menu, and I found the intersection points after selecting both graphs. There are two solutions for this. One where x equals -3, -2, and again one where x equals 4 and y equals 61. So those are two examples using graphing. We'll do some graphing in class to find solutions as well. We can also do this by using substitution. Like always, we would substitute an expression for one of the variables into the other equation. Here, I'm going to substitute for this y in the second equation using the first given value for y. So we will see 2x squared plus 12x plus 17, the first option for y being equal to -x squared minus 6x minus 10. I will need to zero out one side completely by adding a positive x squared to both sides, a positive 6x to both sides, and a positive 10 to both sides. So that will go ahead and zero out the equation for us completely, resulting in 3x squared plus 18x plus 27 equals 0. I do need to make sure that one side is zeroed out completely so I can use the quadratic formula. As I enter a, b, and c, I should come up with a step that looks like this. I'll do 4 things with my first step. I will calculate the opposite of b. I will calculate b squared. I will calculate 4ac, and I will also calculate 2a. So evaluating, again, opposite of b, b squared, 4ac, and 2a. Let's see if we can fix this technical difficulty. Here we go. We should come up with x equals -18 plus or minus 324 minus 324 over 6, which if we go ahead and finish